Like a compound, like a what?
Like a compound.
So, how many would that be? 2? Okay. A combination. So, what do you think a compound inequality would look like? 2 inequalities. So, I'll let y'all finish writing. I'll pause.
I need a glue.
Okay. So, please make sure you add the learning target at the top. And today it says, I can solve and graph compound inequalities. And the date, it is the 5th.
Did you use this color?
Yes. Give it a minute. Like, be patient with it. It's got to have time to stick. Breathe. Where are you going?
I'm putting our glue back. I was borrowing your glue.
Could you wait until the lesson? Like, we don't just walk around class.
Sorry.
Can you do that face again? Can you do that face again? Be careful. Yeah.
Alright, so we're going to talk about, before we write anything else, I don't want you to write this down. I'm going to write a compound inequality up here, and I want you to tell me how you think we're going to solve it.
By solving it.
So this is what a compound inequality looks like. How do you think that we would solve, let me get it to focus. I'm trying, honey. Alright, how do you think we would solve this? Nope, I want you to think before you speak. Take like a whole 15 seconds and think about it first.
Can't really see it.
I know, it's trying to focus and I don't know how to make it stop doing that. Alright, Reggie, what do you think we would do? Where would we minus 2 from? We would minus 2 under here? And then where else? Focus. I'm not making that face at you. Okay. I don't know how to make it not do that. Okay, so we said the 7. So we subtracted 2 from here, and then where?
15. Yeah, 15. 15.
Well, how many inequalities do we have?
2. 3.
We have 2. We have 1 right here, and 1 right here.
Doing it.
But that's good, right?
Can we break it?
No. I don't know.
Let's jump.
Let's let it focus and then.
Let's jump in.
Troy might eat it. Oh, alright.
Oh.
No, let's try that.
Okay. Alright, so we've subtracted 2 here. Some of you said 15, some of you said 7. But how many inequalities do we have? 2. So if we covered it up this way, where would we subtract 2? From the 15. If we covered it up this way, where would we subtract the 2? So if I have it both there, where would we subtract the 2? Everywhere.
What?
So if we cover it up here, where would we subtract the 2 from?
15.
From the 15. If we covered it up here, where would we subtract the 2 from?
7.
If we uncover it, where would we subtract it from? Everywhere. So on compound inequalities, you subtract it from everywhere. You would add it to everywhere. So whatever you do to the middle, you're going to do to both sides. Now, open and, because that's the first inequality that we're going to focus on. An and inequality looks like this. So if we subtracted 2, alright, we would be left with our x in the middle, and we would have 13, and we would have 5. Does everybody agree? Now that says that x is less than 13, and x is greater than 5. That's how you read that. You're going to have 2 answers in and. So right here, and statements will always overlap. So that means that the graphs are going to touch. If it does not overlap, it has no solutions. So then it says both inequalities have to be true for the compound to be true. So that means that x has to be greater than or equal to 2, and x has to be less than or equal to 6. So let's think about what that would look like on a number line. I'm going to draw a number line for us right here. We have 1, 2, 3, 4, 5, 6, 7, 8. All right, how many answers do we have right here? We have 2. Where should we put our circles at?
Right.
And? Okay, are we going to use an open or closed circle?
No, close.
Closed. All right, so we're going to put a closed circle on 2, a closed circle on 6. So what it means by overlap is this says that it has to be greater than or equal to 2, correct? What numbers are greater than or equal to 2?
3, 4, 5, 6, 7.
But it also has to be less than or equal to 6. So what numbers are less than or equal to 6? 3. So they connect and look like that.
How do you get that?
You just connect them. So if it looks like this, they connect. So our solution to our graph would connect. Draw that. Now, this means that one answer is greater than and one answer is less than. Okay? One answer is greater than, one answer is less than. What does this answer mean?
One is greater than and one is less than.
Look again. One is greater than, and which way is this going?
Oh, greater.
That's also going greater. So both are greater. So your answer when you graph it would look like this. I don't know. It's super fun though. I like compound inequalities. And then this guy right here would be a no solution. So if they're going opposite ways like this, do you see how one is greater than and one is less than, and they don't overlap? So here we overlap, here we overlap, here we don't overlap. What did it say if it does not overlap?
No solution.
No solution. Hello.
The sun was coming from over there.
All right, so now that we know what the graphs look like, we're going to talk about what the problems look like. So we're going to turn to the back, and these are going to be in blue on my paper. You can put them in whatever color you want, but mine's going to be in blue.
I like blue.
Okay. Blue? Yeah. Okay. Pencil works as well. All right, so let's turn it over. 23B on the back. Or to the next page of whatever you did. And sorry I didn't print off the problems for y'all already. I got carried away yesterday. All right, solve and graph.
Is this our homework?
So, are we done writing? Are you done writing the problem?
Oh, I thought you wanted to.
No, I don't want you to work it out without me. We haven't done one yet. No. Okay, so we said a minute ago when we did our sample problem that we subtracted 2 everywhere, correct? So this time, what would we do first if it was just one inequality?
Plus 6 on both sides.
We would add 6, correct? So what would we do first now? Add 6 where? Everywhere. Now, are we going to add 6 to the 2x? No, because they're not what?
Same.
Like terms. So add 6 here. Add 6 here. Add 6 here. Yes, no, maybe. We okay so far? All right. Then we kill it in the middle. What's left in the middle?
2x.
2x. Now, keep your signs the whole time. Bring them straight down. Keep the signs. Bring them down. Don't lose the sign. So, -4 plus 6 would give us what? 2. 10 plus 6 would give us what? Are we done? What do we have to do now? Divide by 2. Do we divide 2 everywhere or just one side?
Everywhere.
Everywhere. All right, do I keep my sign? All right, what's 16 divided by 2?
8.
16.
Oh, I thought you said 2.
All right, what's 2 divided by 2?
1.
There you go.
Now we graph.
And now graph. So your homework tonight, I want you to graph that, and I want you to work out this one. All right, so graph A and work out B. Yes. Work out a graph.
I'll try. Yeah, I'm gonna just try.